Every app needs to store data, and the very first big decision you'll make is which kind of database to use. Get it right and everything downstream feels easy. Get it wrong and you'll be fighting your own data for years. On one side sits the relational world, neat tables, strict rules, 5 decades of trust. On the other sits the flexible world, documents, key-value stores built to scale to the moon. People treat this like a religious war, picking a team and defending it to the death. It isn't a war. By the end of this video, you'll know exactly which one to reach for and, more importantly, why. Let's settle SQL versus NoSQL for good. So you're starting a project and you hit the same fork in the road that everyone hits. Do you use something like Postgres or MySQL? Or do you reach for MongoDB or Redis? The internet will scream that one of them is old and dying, and the other is a toy that loses your data. Both takes are wrong. These are simply two different shapes for storing information, each with real trade-offs. The relational side optimizes for structure and safety. The non-relational side optimizes for flexibility and scale. The trick isn't picking the single best one because there is no best one. The trick is matching the shape of your data and the way you'll actually use it to the tool that fits. So let's genuinely understand both, starting with the old guard. The old and proven approach is the relational database, and it thinks in tables. Picture a spreadsheet, rows and columns. Each row is one record, one user, one order, one payment. Each column is a field with a fixed type. This one's a number, that one's a date, this one's text. Before you store a single row, you define that structure up front. That definition is called a schema, and it behaves like a contract. If a row doesn't fit, a missing field, the wrong type, a broken reference, the database simply rejects it. That sounds strict, and it is. But that strictness is the whole point. Your data can never quietly rot into a mess because the database refuses to let bad data in the door. Here's the real superpower of the relational model. You never repeat yourself. Instead of stuffing everything into one giant table, you split your data into focused tables, users over here, orders over there, products somewhere else, and you link them together by ID. A user has an ID, an order simply points at that ID. Then, when you need the full picture, you ask the database to stitch the tables back together on the fly. That stitching is called a join, and it is genuinely powerful. One question, show me every order from customers in Berlin who bought a keyboard, can pull from 3 tables at once and hand you a clean answer. Your data stays lean, nothing is duplicated, and the relationships between things stay honest. Now here's the promise that matters most, especially the moment money is involved. Relational databases guarantee that a group of changes either all happen together, or none of them do. Move $50 from one account to another. The debit and the credit are locked into a single transaction. If the power dies halfway through, the database rolls the whole thing back. You will never lose the money somewhere in between. These guarantees have a famous name you'll see on screen, and together they keep your data correct, consistent, and durable even under total chaos. This is exactly why banks, payment systems, and anything where a wrong number is a catastrophe still run on relational databases. When close enough is not good enough, this is the safety net you want. But what if your data simply doesn't fit into neat rows and columns? This is where the other world begins. Instead of tables, a document database stores your data as flexible documents, essentially the same nested structure you already use in your code every day. Watch what happens to that user record. In a table, it's split across columns and linked out to other tables. As a document, the whole thing collapses into one self-contained object. The user, their address, their list of orders, all nested together in one place, ready to hand straight to your app. There's no rigid schema demanded up front. One document can carry a field that another one doesn't. Need to add something new tomorrow? Just add it. No migration, no schema change, no ceremony. It reads like a little bundle of labeled values wrapped in curly braces. A name, an email, an array of orders all sitting right there. The shape of your data evolves as fast as your product does, which is exactly why early-stage teams love it when they're still figuring out what their data even looks like. And documents are just one flavor. NoSQL is really an umbrella stretched over several very different shapes. Document stores like MongoDB hold those rich nested objects. Key-value stores like Redis are dead simple. Every value has exactly one key and lookups are lightning fast, which makes them perfect as a cache in front of a slower database. Wide column stores spread enormous tables across hundreds of machines for heavy analytics. And graph databases specialize purely in relationships, who follows whom, what connects to what, how deep the web goes. They don't all work the same way at all. What unites them is a shared rejection of the one-size-fits-all table. Each one deliberately bends the rules in one direction, so you can pick the exact shape that matches your problem. Now let's talk about growing, because scale is where these two worlds truly split apart. When a relational database starts to buckle under load, the classic move is to scale up, buy a bigger, beefier machine. More processors, more memory, one very powerful server doing the work. That approach works beautifully right up until it doesn't. There's a hard ceiling, and it gets brutally expensive as you approach it. Non-relational databases were designed from day one to scale out instead. Spread the load across many cheap, ordinary machines and just add more of them whenever you need more capacity. That's how you serve billions of users. But flexibility has hard limits too. A single MongoDB document, for instance, can't grow past 16 megabytes. That cap exists on purpose. It stops you from cramming an entire unbounded history into one giant blob. Even the flexible world has rules. But that speed and scale come with a catch, and it is the deepest trade-off in this entire topic. When all your data lives on one machine, keeping it perfectly consistent is easy. Everyone always sees the exact same latest truth. Spread that data across 100 machines, though, and you run straight into physics. Write after a write, some copies update instantly while others take a moment to catch up. For a few milliseconds, two different users might see slightly different data. For a like count or a view counter, who honestly cares, that's completely fine. For your bank balance, absolutely not. So relational databases lean hard towards strict, always correct consistency, while many non-relational systems trade a little of that away to stay fast and always available at massive scale. Neither choice is wrong. They're simply tuned for different fears. So let's put them side by side plainly, with no hype. Schema: the relational side is fixed and enforced by the database. The document side is flexible and open. Relationships: relational joins cleanly across many tables, while the document world nests related data together and often joins inside your own application code. Scaling: relational tends to scale up on one big machine, non-relational tends to scale out across many. Consistency: relational leans strict and transactional, non-relational often leans fast and eventually consistent. And best for: relational shines on structured data with complex relationships and hard correctness. Non-relational shines on data that's evolving, deeply nested, or genuinely enormous. Same underlying job, store your data, but two very different philosophies about how to do it. When should you reach for the relational side? Reach for it whenever your data is structured and the relationships between things actually matter. If you can describe your data as clear entities that connect: customers, orders, invoices, products, a relational database is an absolute joy to work with. Reach for it when correctness is non-negotiable. Payments, bookings, inventory, anything where 2 plus 2 must always equal 4. And honestly, reach for it as your default. Postgres and MySQL are free, battle-tested, and quietly run most of the serious software you touch every single day. Modern Postgres can even store and query flexible documents when you need to, so you rarely outgrow it. If you genuinely aren't sure which way to go, start right here. You will almost never regret it. Now flip it around. Reach for the non-relational side when your data is fluid, or your scale is extreme, or both. If every record looks a little bit different, think of a product catalog where a book and a couch share almost no fields. Documents fit like a glove. If you're building a cache or a real-time leaderboard, or you just need blindingly fast key lookups, a key value store like Redis is genuinely unbeatable at that one job. And if you're ingesting a fire hose of events or serving a truly global audience, a database that scales out horizontally is the entire point. This is how companies stream real-time activity, store sprawling and inconsistent user profiles, and power the endless feeds you scroll through all day. When the shape of your data keeps changing, or the sheer volume of it is staggering, or you need one specific operation to be absurdly fast, the flexible world absolutely earns its keep. Pick the member of the family that fits: a document store, a cache, a wide column giant, and it will do that one job better than anything else. So here's the simple rule to carry around in your head. If your data has a known, stable structure and lives on its relationships, use the relational side. If your data is constantly evolving, deeply nested, or headed for massive horizontal scale, use the non-relational side. In practice, just ask 3 questions. 1. Do I actually know the shape of my data, and will that shape hold steady over time? 2. Do relationships and rock-solid correctness matter to me more than raw flexibility? 3. Am I scaling up one strong machine or out across a whole fleet of them? Answer those honestly, and the choice tends to make itself. You are not marrying a database for life. You are picking the right tool for this specific job. Here's the honest truth almost nobody likes to admit out loud. The line between these two worlds is blurring and fast. Relational databases now store and query flexible documents natively, right alongside their tables. Document databases have added real transactions and much stronger guarantees. So a lot of the old "this one can't do that" talking points are already half out of date. And here's the real secret that the big companies figured out long ago: you don't actually have to choose just one. Serious systems mix them freely. A relational database for orders and payments, plus a fast key-value cache sitting in front of it, plus a document store for messy, free-form user content. That isn't indecision, it has a name: using the right tool for each job. The best answer to SQL or NoSQL is very often just yes, both. A few things that will trip you up if nobody warns you. First, NoSQL does not mean no schema. It means the schema now lives in your application code instead of the database, and if you get sloppy about it, your data slowly turns to mush. Second, schemaless is not a free lunch. The rules didn't vanish into thin air. You just quietly moved the responsibility for them onto yourself. Third, never pick a database for its buzzword scale. Most apps will never, ever see the traffic that would justify going non-relational, and a boring old relational database will happily carry you all the way to millions of users. And fourth, your very first schema will be wrong, guaranteed. Both worlds make you pay to change it later, so design around how your data will be read, not just how it gets written. Let's tie the whole thing together in 3 lines. 1. Relational databases store structured data in strict tables, link it with joins, and guarantee correctness, perfect for when structure and safety are what matter most. 2. Non-relational databases store flexible documents, key values, and more, and they scale out across many machines, perfect for when your data is fluid or genuinely enormous. 3. There is no universal winner. There's only the right fit for your problem, and the professionals quietly use both without shame. Pick the shape that matches your data and the way you'll actually use it, and every single thing you build on top of it gets dramatically easier from that point on. If this finally cleared up SQL versus no SQL for you, then you already know what to do. Subscribe, because we're going deeper. Next in the series, database indexes, the single trick that can make a slow query 1,000 times faster, no matter which side you landed on. It's quite possibly the most important database skill that nobody bothers to teach you. I'll see you in that one.